This is the Amp Hour Podcast, recorded March 25th, 2013. Episode 138, with guest Ryan Brown, Effortless, Equipment, Extensibility. Welcome to the Amp Hour. I'm Chris Gamble of Chris Gamble's Analog Life.
And I'm Ryan Brown of National Instruments.
Welcome, Ryan. Another solo interview. You're the third in a series.
Yes, I feel like I won a prize. Thanks, Chris.
you won the Don't Have to Deal with an Aussie prize.
Yeah.
So you are now our second guest from National Instruments as well.
Is that right?
Well, right, because you, Matt Edis, you actually were the one who introduced us.
Yes, that's right. Yes, Matt's a great guy. He's a lot of fun to work with. Definitely,
and he's got. If people don't remember, if we can link that show in as well. But Matt started a software-defined radio company that eventually got bought by National Instruments, and now they operate as kind of like a small company within a bigger company. And yeah, very cool stuff. So, what kind of work are you doing? Are you doing similar software-defined radio stuff or other product lines?
Well, I'm more on the digital side, but I work on a product called FlexRio, or Flexible Reconfigurable I/O, and it's meant to be modular, such that people can build things like software-defined radio or control systems or anything in between. So our stuff gets used all over the place. The enabling thing is LabVIEW FPGA. So what that does is, you put these I/O and the FPGA together, and people can customize it to what they need it to do.
Okay. And so is this something, I was looking on the website a little bit with is Flex Rio? You don't say RIO, you say Rio?
Either is fine, but we say Rio, yeah. But okay. And then we say
that's
PXI, not Pixie. So I think it's just, tomato, yeah. Yeah. I remember that from Keithley days. We used to talk about Pixie, so it's weird how those conventions come up, It's yeah, I think so.
Yeah. But yeah, I was looking on the FlexRio page a little bit, and it seems like, is it like something that so if I started a company tomorrow, is it something that I could buy and then develop on top of? It's kind of like a layer that other companies can build on top of as well? Yeah,
exactly. I get to deal with a lot of startups, usually funded startups, because it's several $1,000 product.
Yeah, I was gonna say $5,000 kit, right?
yeah. It's usually not a guy in a garage, but it's nice in that way. We have a lot of IP in moving data between the host CPU and LabVIEW running on the FPGA, and we allow for custom VHDL, and we allow for people to design their own I/O circuits. And so with all of that, you kind of can skip over the boring, DRAM interfaces and PCI Express and configuration challenges, all those headaches, and jump to the DSP that's going to differentiate your company, or the software-defined radio algorithm that you want to experiment with. So we definitely get used by a lot of labs and a lot of startups for that reason. It's kind of like a head start. If you have the money, it's worth it.
Yeah, and it seems like it's kind of like you kind of tack onto this much larger ecosystem with the software and even complementary hardware. Even just like a digital trigger could be something that seems easy in theory, but then if you have like a high current digital input, you might not want to actually use your FPGA board that you're developing on. You might want to have some other module that captures that trigger, and then you do all that in software. So it's kind of it's nice that you get all the extras as well, but I'm sure,
right?
I'm sure you don't get them. I'm sure you buy them.
Yeah, you buy them. The integration piece, is another thing that by having the system level perspective, you can mix and match. Another cool thing that we've built into the back end is being able to stream directly between PCI Express endpoints, and so. Okay. If you have an algorithm with either a lot of I/O or a lot of computation required in the FPGA, deterministic computation, we have that direct link. So it's another vector of expandability to build, a lot of times things like radar, where you have a lot of channels and a lot of math that you need to do. And and that can come in really handy. And there's not another great way off the shelf that you can do that.
Right. Right. So, well, let's take a step back a little bit. So, I mean, actually, we often get a lot of questions. I mean, from the survey, which people should be taking right now, of course. But there's often a lot of interest in FPGA stuff. So maybe could you give us a little background on how you got started in FPGAs and just your experience with them?
Sure.
Growing up with this product line and everything as well?
Right. I mean, I took a couple of digital classes in college, learned Verilog, and when I did an internship at National Instruments, we like to give our interns real products to work on, and so I had a product and a deadline that required VHDL, so I kind of switched at that point.
Nice. Yep.
And learning by doing. And in 3 months we shipped it, and I got up to speed. And since then, I did my senior project in VHDL, and kind of been hopping back and forth back then between Xilinx and Altera, the two kind of main players that you guys have talked about before. A little bit Lattice thrown in here and there, but the way that we develop here is, even as a new engineer, you kind of have full responsibility for a given project, and most of our projects are anywhere from 6 months to 24 months, and so that kind of forces you to learn all aspects of a design. Now, as you get more advanced, we do have digital and analog separation like most places, but the first product I worked on was called the 6552, which is a kind of a digital ATE card for testing, digital pins on chips. Then I developed the 6542, and all of these had, fairly similar VHDL for streaming data to and from the host CPU, constructing patterns, checking for errors and responses, setting voltages, things like that. So from a product perspective, it was a good mix of digital and analog. The pin electronics kind of was the main analog, and of course power supplies and clocking, things like that. And so that's kind of where I did the most direct development as the process of learning the NI development flow. And then back in 4 or 5 years ago, kind of got challenged with coming up with a modular product that could expose the FPGA, the full power of the FPGA to more people. And so that's what the FlexRio product line came out of. And the interesting thing, coming from kind of a hardware FPGA background and developing something that's meant to be used by people writing code in LabVIEW, is you kind of get pulled up, right? And it's kind of fun to be.
They just say I just want access to this API, instead of, they're not saying I want to route traces on a PCB. They just want to get it done, right? They just want the high level.
Yeah, exactly. And it's a fun tug of war between guys like me coming from the digital side or the hardware side, and guys coming from the high level abstract software side to figure out how do we build things. But do you get away with it though, where they're like, well, we probably are willing to wait, a couple milliseconds or whatever. You're like, I could do this in microseconds, but I'm not going to tell them. That's a big kind of, I don't want to say a gulf, but there's a line in what you can achieve, deterministically at different levels of abstraction, and we do a pretty good job of that. There's different tools that do that, and we don't want to force users down into counting flip-flops and understanding delays and things like that. We want to allow them to provide maybe a more, what they care about, right? I need to update this pin, 10 microseconds after I receive this trigger. So building a tool that can allow that is quite a challenge.
Especially making sure it always happens the same way. And
exactly.
You can have a lot of variation under the hood there too. So that's
right. And
that's not easy.
Our tools, compile down using the standard FPGA build tools. So there's additional variation in what they may do from run to run. So there's definitely a lot of challenges in that abstraction.
So how much does it mess up you guys when say Xilinx redoes their command line flow or something like that, and does that hit you guys pretty hard? I mean, is that like a big wrench in the works?
Yeah, we're fortunate that we have a lot of contact with Xilinx. My
Oh yeah,
products use Xilinx FPGAs, so
yeah.
we're definitely not blindsided. But is being the
It still
abstract,
sucks.
yeah. Well, there's to build a abstraction that to some extent stays the same over time. Somebody's going to have to pay a tax to adapt. And fortunately, Xilinx gives us a lot of help to maintain that. And right now, there's ISE is kind of fading out, and Vivado is the new Xilinx tool
really?
set. And
Is it Bravado? Is that right?
Vivado.
Vivado.
Yes.
Okay. Yeah. I guess I've been out of. I really haven't been doing FPGAs lately, but I had in the past. So I've experienced the ISE. Is that like the new? Is it like the command line flow stuff with it? I mean, I guess it's always been command line stuff, but is there something different, or is that just when they moved to?
I don't know a lot about the underlying guts of what's new with Vivado, but it's definitely a different compile flow from a tools perspective. I believe it's closer to Plan Ahead from a UI perspective.
Oh, I remember them talking about that. I like sat in on some lunch at one point. I remember them saying that.
So Plan Ahead has some pretty nice features for obviously planning pins, but also planning where stuff goes and constraints and giving you visibility throughout the flow. So I think Vivado is continuing in that direction.
Right. Yeah, and so people that are kind of new to FPGAs too. I mean, I think some of that was based on because of these new FPGAs, they have not just completely reconfigurable everything. They also have hard blocks where you definitely have to route signals to a certain part of the chip, and I think that probably plays into a little bit.
Yes, like for example, the PCI Express cores. Is one thing that's can be handy, but even the DSP and the block RAM that are spread throughout the chip. If you're pushing the clock rates, to several hundred megahertz, you do start to care where things are.
Right, that always bugged me too. You compare. I know it's not a real comparison, but it was just like, come on, go faster. I know I can get like parallel, benefits and all that other crap, but sometimes you just want to see the clock rate go faster.
Yes, yeah.
It's like a machismo thing or something. I don't know.
And then there's you want the compile to go faster, right? Like that's the.
Oh yeah. So how do you guys deal with that? I mean, so you guys, abstract all this stuff out, but you're still using that stuff underneath. Is it like you tell the user, well, come back in 6 hours because that's what we have to wait for? I mean,
well, we do our best to compose the files that we provide the Xilinx tools in an efficient way to have as low of compile time as possible. The other cool thing that our tools do is we allow using what's called a compile cloud, so you can just farm out compiles to computers somewhere else. So while you won't get your bit stream back for 6 hours, you won't monopolize your processor either.
Yeah, right.
So there's kind of a best practice in how you can farm off a compile, continue working on maybe your CPU, your host side code, or other parts of the application, and get it back and test it and so forth.
That's not as bad as it used to be. I remember I used to have a single core processor, and I would hit compile, and it'd take up 80% of the capacity there, and then even like browsing web pages was bad. It's like, all right, well, I'm going to read something paper now.
Yeah, exactly.
Yeah, screw this. No, it was 6 hours still because it was I was a co-op at the time, and I just had crappy computers. It's just like.
Well, it's definitely we do a lot of instrumenting compiles, and if you exceed your RAM, your compile time is going to jump exponentially, get paging and stuff. So there's definitely a sweet spot to the hardware you can give the compiler.
Yeah. So how much? Okay. So this is kind of like you guys are dangling a bus out there, almost. I know it's not exactly that, but it's like you're basically giving access. You're like giving a window to the LabVIEW world for custom hardware and all the other stuff. How much standardization is there on that side of things? So like if I came up with a software defined radio, is it just like talking to a memory bus? Is that kind of the idea of hooking into the system, or is it a lot more complicated than that?
Well, for my product specifically, the FlexRadio, so we do this in different platforms, but I'll speak to mine.
Oh, okay. Okay.
The intent of our design is to expose the full power of the FPGA that's on the board. So we have what's called a component level IP, which is actually VHDL or Verilog that lives alongside your LabVIEW code that can handle the low-level interaction of the I/O of the FPGA to your custom board.
Oh, interesting.
So where you may need to do, capture data from an ADC that's, running at 500 megabit or a gigabit, you need to instantiate an iSerDes and potentially do some dynamic phase alignment and other things.
Yeah, I hate that stuff.
That's where we expose the full power of the Xilinx FPGA. Now, you don't have to do that, but we wanted to enable anything that you could connect to a Xilinx FPGA without LabVIEW or without our product. We wanted to enable that with our product. So there's really nothing there in your way.
Okay, so give me a little better idea here, though. Okay, so say I am doing that where I have I need to use a SerDes to talk to an ADC or something.
Mm-hmm.
Is it like you would sell me a board that actually has an FPGA already on it with that IP in it, or is it like I put down an FPGA and then I pull in your code and IP and everything?
So the FPGA has fixed IP for the bus interface, the DRAM, the things that are always there. It has kind of a window where you can plug in your LabVIEW code, and it has a window where you can plug in your low-level logic that interfaces to your circuit. So we have example VHDL for talking to your circuit, but you would write that low-level code to configure your clocking chip, monitor your temperature, capture the data from an ADC, whatever your circuit required. So we have what's called a module developers kit that documents all of the timing constraints, all of the mechanical constraints, because we have an enclosure and an I/O window, and kind of provide this kit to hopefully give you as much as you need to build that. And we've had a lot of those implementations.
Okay, that's cool. That's really cool. I mean, it seems like a good idea for getting started and everything. So let's get to the elephant in the room.
Okay.
LabVIEW. It's a beast. It's an elephant. Prove me wrong. I think so. Me and Ryan were talking about this before the show, and I think me and David brought it up before. I have these absolutely wild preconceived notions because I really haven't used LabVIEW much, but I've always thought of it as kind of like a very high level, but also kind of top heavy software because it just does so much stuff, right? There's so many plugins and everything, and it's just taking advantage of cheap PCs, basically. Abundant hardware, or PC hardware. So, what's the deal with LabVIEW? Give me some.
Okay,
give me some help here.
Let me remind you that I design hardware, but I use LabVIEW quite frequently. Yeah. You're right. There are tons of different ways. There are tons of different things that LabVIEW does, and there can be a lot of toolkits and a lot of things to keep track of. I work on I actually do contribute to the LabVIEW FPGA product from a software perspective, and it's a constant battle to provide enough power and control to the user, but also abstract and not, provide the space shuttle cockpit of knobs and buttons and sliders and stuff like that. So I think with any kind of abstraction, you're always walking that line, and you have things like progressive disclosure, so people can dive into the level at which they're comfortable. But I think we do our best to provide that abstraction while also providing as much power as customers need to build their applications. I think if you probably haven't seen, but in the keynotes that we do at our yearly conference in iWeek, there's a lot of different trends that they show over time, and over time the LabVIEW load time is obviously decreasing. That's something we're very cognizant of. The number of bugs per release version or bugs reported, or there's some metric that they track. And so there's definitely a major emphasis on improving the performance while maintaining that abstraction and providing that power. And so, I think...
Well, it's tough too. It's so like, I always thought, I always look at it, right? So, hardware guy here, right? I always look at it as like, okay, I want to flip a bit. I don't want to necessarily, dive down through 14 layers of software in order to do so, right? So I think, well, why not just code up a micro or code up an FPGA to do that myself? So that's data point number one. Then I go talk to a scientist who says, I don't have time for this crap. I want to just get some data readings back. And I have this budget of money, right? Because, I mean, LabVIEW, while good software, is not cheap. So they just say, okay, I just want to do this. And it's like, well, yeah, you talk to someone like that. They love it because they want to just they want to go from plugging in a sensor to wiggly line on a page, right? That's the scientist view of it. If scientists will forgive me.
That's in my experience, that's pretty accurate. And so, how do I make you and him happy, right?
Right, exactly.
So
you don't. I mean, that's the thing. You don't. You get people complaining on podcasts. I'm sure there's science podcasts out there being like, why are there all these deep options that I have to deal with? Like I have to do 3 pull down menus.
Yeah, it's interesting. One of the things that's really cool that I get to do is sometimes travel and meet customers or go to a conference on a specific topic, and I definitely hear both sides of that. We have guys who come from being low-level FPGA developers who want access to that knob they're used to tweaking, and we have scientists and what we call domain experts who may know radar or astronomy or radio astronomy, and
yeah,
and they complain that, well, when I try to drop down an FFT, I just want to set this and this. I don't care how many clocks it takes or how many DSPs you consume. Just give me my FFT.
Right. I've got a Cray supercomputer in the back of my lab. I'll just put it on that. Or something.
Exactly.
These guys are used to that. Yeah.
The one thing that when we developed the Flex Rio, we implemented this component level IP. So if people really wanted to build low level code, they can take their existing Verilog and VHDL and just drop it in. Constraints everything. And so that's the way that we allowed the full path all the way down to the bottom. But you're right, it is a constant pull in both directions.
What's the makeup of like people there? Is it pretty software heavy? I would guess. I mean, what's the mix?
I don't have a good feel for that. But
everybody's got a feel for that, because then you grumble, there's so many software people. I guess you're kind of in the middle anyways, so
yeah, I'm
you can't
in the
really
middle,
say that.
And a lot of us, a lot of the people I work with are both. They do kind of LabVIEW and FPGA development, but that's one of the things that they tell us not really to talk about.
Oh, gotcha.
Don't give team sizes. Don't give
Oh, yeah.
So
that's fine.
If I did know, I probably wouldn't be able to tell you.
Okay. Well, that's cool. Because it just seems like, because LabVIEW is so big, it's just like, it seems like it would be a lot more software people, and also because National Instruments used to recruit at my alma mater too, and it was always just like a lot of software kids would get recruited, and so that's another thing though. Oh,
well,
no, okay.
I don't. We do have a lot of people working on LabVIEW, but you saw the breadth of our hardware products, so we have a lot of people working on driver software as well, and then all the hardware guys to build that hardware. So I wouldn't say that it's mostly application software. I mean, again, I don't know, but I don't think we're that heavily weighted.
I put firmware guys in the software category. Don't kid yourself. if you're not using CAD, you're a software guy in my book. I mean, you might even be in that camp too. Sorry, Ryan. I mean,
oh gosh, that's harsh.
Yeah, it's okay. Well, what about the? I always read about the. Like the workplace style there. It seems like, so I used to live in Austin. I knew a couple guys that worked there. I didn't know you when I used to live down there, but it always seemed like a pretty cool place to work. What's it like down there?
Yeah, it is. We win those 100 best places to work awards. I don't know what the criteria for winning those are, but
I assume ping pong tables is part of. I think there's a whole category for that.
Yeah, one of the. I guess you're one of the few people I know who's actually left Austin, but living in Austin's a pretty cool benefit. Right. As I mentioned, people generally have full responsibility for a project. So, as a builder or maker, you kind of like to do that rather than design on a committee of, 5 or 10 people. Not to say that, we have platforms and other things that take more people. It's laid back, but everyone's pretty focused and pretty intense in their work, and Dr. T, our CEO, is very technically involved and sharp. So it's not uncommon for him to show up at your desk and talk to you about some implementation or some technology.
Oh, really?
Yeah.
Is it terrifying or no? Is it pretty laid back still?
It's. I don't think it's terrifying, but he's
not terrifying, but like anxiety inducing at least. Like,
no.
Oh, hey, you run the place? Oh, cool. How you doing? What's up, man?
No, I wouldn't say anxiety inducing, but it does encourage you to be prepared to dive deep on whatever you may be working on, because you never know what arcane topic that he is. I mean, he's one of those guys that knows a lot about a lot, and so you never know what he's going to ask you about.
Yeah. And so Dr. T is James, is it Truchard? Is that how you say it?
That's right. Yes.
Yeah. Yeah. And so he gives a lot of those keynotes too, right? I think you sent me links for that in the past.
He does. He does I think the day one keynote at NI Week every year, and he travels around and speaks at other conferences. But
he seems like he knows his stuff, and I respect that. I mean, so he's a technical guy. He's still CEO. Is that right?
Yes.
Yeah. So, hey, engineers in charge.
That's right.
I can get behind that.
Yeah. I think he's a PhD in physics, but he started out designing sonar, I believe.
That's pretty cool.
At the UT labs here near where NI is. And so him and the other two founders kind of were in engineering development roles, and then they kind of spun off and started this company.
Yeah. I'll put the wiki page on there too, because I remember reading about it in the past. It was basically having more accessibility and stuff like that. I remember reading about that kind of thing. It's an interesting story, and they had a lot of trouble at first too. I remember reading, just because the tools that were available when they started was it 70s, I think, or 80s maybe.
I think the company was founded in 78, I believe, or 76. I didn't prepare on that.
Well, whatever, it's fine. But I mean, you think about it. They think about the tech of the era, right? It's like you can try and visualize technology now, right? It's like everything's GUI type stuff now, but back then, 6502 kind of stuff. It's like screw that,
The first kind of product was those GPIB interface cards to connect instruments right to PCs or to computers, and I believe LabVIEW was first developed on the Mac.
Interesting.
Back in the early 80s.
Yeah. GPIB. Ugh. It's still around too.
Still around. Still used all over the place.
It'll be there forever. You know what? My theory with this, right? Because having worked in the measurement industry in the past, is that no one wants to throw out all those cables. If people don't know, GPIB cables, they look like the really, really old printer port cables, but they're like, I mean, they've got to be like a 1/4 inch thick. They're like flame resistant or something.
Yeah, they don't bend, and they have the thing.
They're heavy as hell. They're like steel on the end. And probably not actually steel, but that's my theory, is that no one wants to throw them out.
The mating interface is at perpendicular from the actual cable, so you've always got a kind of like interference, or at least all the ones I've used.
Yeah. Oh yeah. Yeah. You mean like where the cable runs into other plugs and stuff?
Exactly. Yeah.
Yeah, and it's a standard. That's right, folks.
That's right.
IEEE 488.
Well, I tell you what, when we started any product that I've started working on, choosing the connector, boy, is that a fateful decision that you're going to live with for a while, right?
Yes, it is. I think everyone could probably, every hardware person could attest to that.
Kids, choose your connectors wisely. They'll be with you longer than many things.
Yeah. Mama didn't raise no connector fool. Oh man, yeah. So let's see. So we talked about NI. I've given a little jab towards LabVIEW, but you've deflected my attacks.
Well, hey, you said you haven't tried it in a while. You know that you can get a copy of LabVIEW from SparkFun now. So
I didn't know that.
Yeah.
Interesting.
So you could buy it's an Arduino plus LabVIEW bundle. I think it's $50. So it's a student edition of LabVIEW. Definitely, a pretty cheap way to get a copy.
See, now right there, that seems like the nouveau heavy-handed way. I mean, like Arduino by itself is pretty it's pretty high level to start with. It's like, oh, LabVIEW on top of that, huh? But again, you're like you said, I haven't tried it, so
Hey, yeah, don't knock it till you tried it.
Yeah, and I ended up eating crow with Arduino too, so you know,
I wasn't aware of that.
No, well, it was just like it was the same kind of thing, right? It's like I look at LabVIEW, right, and I think, God, why don't you just get down in the hardware? And then I said the same thing about Arduino. It's like, wow, why don't you just write some C? And that's not the point. It's twofold. One is it gets you involved in technology on both fronts. I think like so if you have a scientist who's afraid to get into hardware, they're doing work, but then that also sparks interest in hardware. That alone is important. But then sometimes it's just you don't have time for it, and that's the thing that I think a lot of hardware guys or just EEs in general don't think about. It's just sometimes that stuff isn't the focus. Sometimes it's just about getting the measurement out, and it doesn't matter how you do it. And I've come around to that, but it was a hard fought battle. I think it was just me being an idiot too, So
that's fun to be a contrarian, right?
You just summarized the show. It's fun to be a contrarian. You might have come up with the maybe that'll be the T-shirt design.
But you have to pay a tax sometimes, right? See, sometimes you're wrong. Yeah. Pay the tax, but continue.
Exactly. Well, that's cool though. We'll have to. I'll link that in too with the Arduino LabVIEW thing. What about other? How much other expo? You said you were developing other stuff in the past. Do you see a lot of stuff throughout the company and stuff as well? I just said stuff like 3 times in a row.
I'm fortunate. The technology that we work on gets reused a lot throughout the company.
Oh, okay. Yeah.
So we definitely have a lot of visibility, and that can be good and bad. Sometimes you want to design something with minimal external requirements, right? And sometimes that's not possible. So we do our best to design things as flexibly as possible, have decent documentation, and we have a concept called a tech lead. I don't know if that's a standard term, but you're basically a kind of a decision maker, mentor, design reviewer for other engineers, and so where our stuff is reused, we're often the tech lead of those projects. So again, that extends your visibility. And design reviews aren't always the funnest thing to do, but it is fun to kind of learn about a completely different platform than what you've been designing on.
Yeah, and it gives you good feedback for the next generation too, right? It's like, oh well, Mike over there is using it like this. Maybe I should actually incorporate that kind of thing the next time around, or have that extra flexibility so he doesn't have to write all that code and whatever.
Yeah, definitely. It's internal customers. It's very good to sort of eat your own dog food or watch someone else eat it, I guess.
or review someone while they're eating it. Design reviews. Are design reviews pretty rigorous there? I've kind of seen a couple different in my past work, a couple different levels of design review, but I'd imagine with like a system level focus like you guys have, it might be a little more important.
Yes, I would say they're pretty rigorous. My first design review, I recall vividly. I walked into a room.
Oh, these are good stories.
Yeah, I walked
the Lion's Den.
Yeah, the Lion's Den. It was my first board that I'd been fully responsible for myself, and I walked in with probably a stack of papers, data sheets, test reports, everything I've generated. I don't know, 2 feet tall or 2 stacks 1 feet tall. I don't remember. And it was a bunch of. So I was a staff engineer, I guess, at that point, and it was a bunch of principal architects. You can
say it. Is codgers the right word?
What I vividly remember, there was 2 grizzly analog codgers.
Oh boy, yeah.
And as a digital guy, those guys are just out to get you,
Yes, they are. They are. Because you don't know a goddamn thing about decoupling or signal integrity and all that. Yeah.
Oh, I got nailed on a switching power supply feedback, and they weren't visibly having fun, but they were definitely having fun.
Yeah.
And we fixed it, and I definitely learned, and it's we do that, right? Not only do we want the product to be very high quality, but it's part of the way that we teach engineers to design and test and evaluate things and document things. So I would definitely say that we have rigorous design reviews here.
Well, that's good. No, that's a good thing. I mean, if it's built into the system too, that's really important. You know, having it as a cultural thing at a company it sucks. I mean, let's be honest, right? I mean, like, no one likes design reviews except maybe that analog guy. I think personally, I think that part of it is him taking you to task, is also him, you know, it's revenge for having him there at, like, you know, 3 p.m. on a Thursday or something. But
yes,
you know, it is important, but it sucks.
Yes,
I hate them personally.
Well, I think the way to get through them is to try to learn something, right? You know, I think I've heard VCs when you interview a person for a job, if you can learn something from that interaction, if they get the job or they don't get the job, at least you were able to, you know, do something productive in that 45 minutes. So in a design review, I always try to, you know, at least learn something. And now sometimes I get to scold a young analog engineer. So
yeah, oh, that's good. A payback.
A little payback.
Yeah, that's good. That's good. Oh man, that's fun. Well, that's cool, man. So, and you said you get to, you know, kind of see outside stuff now too. Is, I guess, you know, I'm sure you're moving up in the company and everything, but you get to interact with customers, internal, external, all that stuff. That's always a lot of fun as well. Probably getting to see different applications.
Yeah, totally. I don't know if you saw, I posted a picture. I got to go to the Green Bank Telescope last year.
I did. Oh yeah, I got to post that.
Yeah, it was.
So what was that like?
I prior to that, and I went with John, one of the product managers at Edis.
Okay.
And it was a really cool workshop. It's the Casper workshop, which is all for radio astronomers, and learned a lot. And prior to that time, I was not the most comfortable with heights. I wouldn't say I was afraid, but I didn't really seek them out. And basically, John goaded me into going to the top of that. It was raining. As we were about coming back down about halfway, it started lightning, and our guide was one of the installers and maintainers responsible for crawling through all of the support structure and aligning all of the panels, because that whole thing is made up of these panels that have to be perfectly aligned to focus, you know, the received energy. And
wow.
And they have all these actuators to maintain the alignment, but when they need to be adjusted, these guys just crawl out through this. And so he was walking all over the dish, you know, 400 feet in the air, and it's wet, and there's lightning, and about 5 minutes of lightning. He said, "Well, you know, I guess we should probably get off this and get back down to the ground."
Oh my God.
But in hindsight, I'm glad, you know, if John listens to this, thank you, John. I wouldn't have gone up there without your, insisting and pushing me onto the sideways elevator.
Wow. I don't know, man. That's I'm not a heights person either, but that's intense.
Yeah, you can't have,
because peer pressure helps.
Peer pressure helps. Yeah, and only because we were there with the scientists who run the place did we even have the opportunity to go up there. So it was kind of a one-time chance.
Yeah.
But we got one picture, because you can't take electronics anywhere near the whole area where they have the telescopes. Yeah. So one guy had a disposable film camera, and you can see like my hands are on the railing and my knuckles are white.
Yeah. No one's blaming you for that one, I'll tell you that much.
Yeah. But that's the kind of visit that I really, try to take advantage of if I can arrange it.
Yeah, and remind me where that was. I remember you told me at the time when you had tweeted that picture, but I don't remember now.
Green Bank, West Virginia, is where the Green Bank Telescope is.
Yeah, and I remember seeing it. It was like it was off in the distance, but it's still, you could just tell the massive scale of it. It's insane.
I think they say it's the biggest, movable land-built structure or something, because it rotates, and so there's some criteria where it's the biggest in the world. Yeah,
right. I always think about that one that's down in South America that was in Goldeneye.
Yeah.
That's one I always think of.
Arecibo. So some of the guys who were there at Green Bank were comparing it to Arecibo. And apparently at Arecibo, there's a cable car that takes you to the receiver room, which is suspended on those cables. above.
Yeah, dude, I've seen the movie. They
I
shoot guns off that thing.
Okay. I haven't seen it.
Watch your GoldenEye. Jeez.
No, I haven't seen it. I'm sorry, but
Or
apparently
play the video game, N64.
Are you old enough for N64?
Oh yeah, for sure.
Yeah, well, apparently some of the guys who run the cable cars are a little bit, more wild with your person than you might be yourself. So.
Oh, well, they like start rocking the boat kind of thing.
Yeah, exactly.
I hate when people do that kind of thing. They've just played. They know the limits. They can feel. They've got the feeling. But with heights and that kind of thing, it's just like any small. Like, let's just be honest. I get scared at the cable cars at like Cedar Point. Like those things. If someone like shifts a little bit in their seat, I start to quiver. So
right.
Yeah. I don't like when they do that. Okay, so let's see. What? So Austin. I mean, you're in Austin, obviously one of my favorite towns in the world. What's the tech scene like that? Like down there, other than NI? I mean, is there other stuff that you see that you interact with?
Well, so there's definitely the hardware scene is pretty good here. We have obviously Dell is a large a large hardware focused company, but Motorola and Freescale and Samsung is AMD, Applied Materials. So there's a lot of hardware talent. I'm here, and so that's starting. You're starting to see more and more smaller companies starting here with a hardware focus. So a lot of people I've gone to school with and other engineering friends are doing a lot of different things. So I think the scene is pretty good. We have the other side of the spectrum. We have a mini maker fair, and we had full maker fairs back when they traveled around, and pretty well attended. I don't know the numbers, but every time I've been, they've been very packed. And we have a Dorkbot group. We have a couple of hacker spaces, and we have a tech shop now. And then the kind of software-focused startup scene is pretty good too. It's growing, and you see that with South by Southwest. There's a lot of local companies participating in that because it's in our backyard. So,
right. And what about South by? I mean, that just happened. So, how was that for you? I mean, did you get out there a lot, or was it more of was it kind of during work hours?
Well, no, I went out. I went to the interactive portion of South by Southwest this year. We were fortunate enough. I hosted an event, the Hardware Startup Meetup. Nick Pinkston out of the San Francisco or Bay Area, one of the San Francisco Hardware Startup Meetups, kind of set the stage for, and then I was able to kind of figure out how we can do it with who is in town. So through that, I was able to go to some other South by events, and it was a lot of fun. There was a lot of so I went back in 2011, and this year it seemed a lot more hardware company presence than in years past. The Create, so there's many different subsections of South by Southwest, but there's a section called Create that's open to the public. That's kind of like a Maker Faire-esque component, and
it's like art focus, kind of that kind of festival feeling.
They had
like walk around.
Yeah, exactly. Tents, you walk around. But Autodesk had a big area. The tech shop guys were there. SparkFun was there. TI was there. Our hacker spaces were there. There was the guys who did the Boosted Boards Kickstarter were there.
Boards. Which ones are those?
It's an electric skateboard.
That's right. Did you try that out? Because I always wondered how they got so much stuff into like those little. I mean, it's just within the wheel casings. I mean, really, the axle covers.
Yeah, I did not. It looked like a pretty impressive industrial design, and they were riding them all around. But
yeah,
I'm not a
like
competent.
Fast? Was it like fast? I just think of the torque and the motors you need and everything. It just seems like, maybe you get like 5 minutes on one of those things. That's just what it seems like. But I don't know.
Well, there were so many people. I didn't see them go full out, but I did watch their video, and it looks like they go 15, 20 miles an hour. But
wow,
I don't.
That's crazy.
Yeah, it's a pretty impressive industrial design. It looks really good. I don't.
Yeah.
Obviously, can't speak to how well it works, but
right. And that is often a marker of the new hardware startups kind of scene. It seems like there's often a lot of focus on design and
Yes.
more than just the electronics or anything. There's also good industrial, good software on top of it. That kind of it seems like it's a little more all inclusive, even with small teams.
Exactly. The right next to them, you'd be interested. There was a guy out of Chicago named Jeff who's working on a pick and place machine called Board Forge. Have you heard of this?
Oh yeah, you didn't listen to last week's show apparently because we mentioned it last week.
I'm sorry, I didn't.
Oh, the truth comes out. It's been too busy at work. Yeah, no, we did see that though because someone did an interview. I think it was Slashdot had an interview posted.
Okay,
with him.
yeah. So he had it there, and he was demonstrating the kind of a couple of simple movements, but it looked pretty neat.
Yeah. Yeah. And now if Dave was here, of course, he'd be, no, yeah, you don't need a stupid, however Dave talks.
So I did listen to the Mike's electronic stuff.
Yeah.
And Mike has a pick and place, right? And Dave.
Yeah, he has a commercial one, but yeah, it is a smaller commercial one. Yeah.
Okay, so somewhere there's room for that, but I guess.
Yeah, true. Yeah, there is. I mean, like even we mentioned last week when we mentioned the Board Forge is that Dangerous Prototypes got one, even though they've always said they don't do in-house pick and place stuff. But it's just there's balance points. I mean, even Adafruit starting out had the smaller one, and now they're moving to bigger pick and places, and it seems like that's just an evolution. Eventually, it makes sense. I actually, last week I saw the Tiny Circuits down in Akron. Ken, I heard him talk, and he gave a really good example of why you'd want to do that kind of thing. And basically, it's to reduce setup costs. At a certain point, there's a balancing of, if you have, say you're only doing maybe 500 boards a month, even if that's, only 10 panels or whatever, big panels, of course. The being able to keep your setup the same for not having to unload reels and reload them and everything, there's a lot of economic benefit in that because that's often a large part of a board population setup.
Yeah.
So having that, if the cost of a pick and place comes down enough and it's decent enough accuracy and you don't have to have a lot of interaction with the final product and it just kind of spits it out, which is of course a bit optimistic. There is a balance point there.
Okay.
So, I don't know. So you ran though. So you are in charge of the hardware meetup for Austin, though, right? I mean, like that's your thing.
Me and my friend Bartley started up last year, and it's just been trying to build a way for people frequently ask, I need help debugging this circuit, or I need somebody to write some C code for this, micro, or I need an industrial designer, and so we wanted to have some meeting point or way for those people to meet each other and a way for some of the Austin companies who are building cool stuff to show it off. So I had both been in kind of know people in other sub communities in Austin. The Austin has a Ruby on Rails group that's very active. It's a great community. And so I got some advice from some of their guys about how they grew and what they prioritize and how they structure things. And so we're doing our best to do something similar where people can find people to help them. And we've had, I think, 4 or 5 events so far, and pretty good attendance and pretty good feedback. So we're going to do our best to keep it going, although it's a lot more work than I expected.
Oh yeah, I believe that. So do you guys do it like how they do out in San Francisco too, where you have like local companies sponsor a certain meetup as well?
Yeah, we're trying that.
Buying beer and food and stuff.
Yeah, we our first sponsor was the company that Bartley actually works for, called Chaotic Moon. And they have a labs group. And so Chaotic Moon does a lot of interactive development of apps and things like that for big brands and big names. And
cool.
A lot of the stuff that they do has a hardware component. And so there's a small team called Chaotic Moon Labs that builds these hardware elements of whatever app they may be, like and they do a lot of things that get a lot of publicity. You may have heard of the Board of Imagination. It was a skateboard that was controlled with one of those emotive headsets.
Oh, is that the headset? Yeah.
Yeah. So they do things like that, kind of integrating different technologies and making something interesting. But anyway, they sponsored our first meetup. They're in Austin hardware software company, and then our next event was sponsored by Xilinx.
Oh wow, okay.
So that was pretty cool. They had a few guys there to talk about Zinc and the new kind of all programmable stuff. So
yeah, that thing is a beast.
Yeah.
That thing is a bit over the top for, I'd say, most people, but
it's pretty awesome.
Pretty cool.
Yeah.
Have you used one?
Yeah. We have a couple dev boards and played around with them a little bit.
Yeah, I got to see. I think it was the ESC last year. They were just coming out with silicon at that point, and they were like emulating with like 6 other FPGAs or something like that.
Yeah, that emulation system's pretty neat.
Yeah, it's great. It's just crazy. It's just. I mean, I don't know. I'm a perennial cheapskate, so I look at these things and I'm like, well, who the hell is going to use this? You're never going to use this in a volume production. And then they turn around and they look at me and they're like, of course you're never going to use this in a volume, in volume production. So, maybe once in a while, but it had to be very, very high volume.
Yeah.
So, it's it's a weird market that I just don't play in because I don't do high performance stuff. So
yeah.
Well, that's pretty cool though. That the hardware meetup. I mean, and then you guys do the same kind of thing where you'll have people come in talk about what they're working on from small startup perspective as well, like
yeah, exactly,
small teams.
Well, so Nick out in San Francisco, he's just opens it up. It's kind of a pitch after pitch after pitch. I think everybody gets 2 or 5 minutes, and so they have so many people that they fill up an hour or more with that. We do it a little bit more formal. I mean, maybe more structured is a better word, where we have somebody talking about a topic we feel is useful for most of the people interested in building hardware, like industrial design or rapid prototyping, or somebody who's kind of gone through building their own company. Our first meeting we had John and David from Super Mechanical. I don't know if you remember. They were kind of the first Internet of Things Kickstarter that really blew up.
Which product was that? I remember hearing the name, but
Twine.
Twine, that's right. Yeah, the little blue thing that has like a sensor in there and it's web connected and everything.
Yeah,
it was like $199 or something too, wasn't it?
Was it that much?
It was a lot. I remember being a lot. I remember being like, "This is so, oh my goodness!" But it's it's just because they're getting started. It's like I'm sure that cost comes down. So
yeah,
they did awesome. Did they break $1 million?
No, I think
they broke a couple 100,000, I think, or something.
It was like $550,000.
Not a small amount of money.
No. So, and the cool thing was they were MIT Media Lab guys, and they actually moved down to Austin. I think because they like Austin, but they have family down here too. And
those Media Lab guys, and gals, sorry.
Yeah.
Them and ITP and all those like mixed mediums things, like they always seem to come up with crazy. Like, did you see Matt Richardson's bike light thingy? Did you see that video he made?
No.
He put like a Pico projector and a Raspberry Pi together. It's just like, who comes up with this crap? Seriously, what? He does, and other people do. It's just cool. It's cool stuff. Because they have to touch on a lot of media. I think that's the kind of, you think about hardware startups and everything. That is the kind of future thing where you can't just be, you're not just going to be making a PCB anymore.
Right.
Even with mixing analog and an FPGA, that's not enough either. You need to have software layered on top. You need to have, web stuff where, the interactive and everything. It's just, God, it's hard.
It is hard. Well, John and David were pretty fun to hear about their progression because, like you said, they'd made some crazy stuff in building towards Twine. One of the examples was John, I can't remember what he called it, but it's a wallet with some kind of an actuator that actually gets harder to open as you spend more money. So it prevents you from opening it when you've spent, your allowance.
Yeah.
And then after that, they built a table that had, I think it had a QR code, a big QR code that had the full CAD design for that table embedded in that URL and that QR code. I don't remember exactly how they structured it. But they'd kind of done a couple of these, interactive builds, and that led up to this Twine thing. So not a lot of
it's not where you start, right? It's this Twine is the end goal. It's not like where people are just like, oh, I think I'll just make this thing.
Exactly.
It's like, no,
it's
they're
just
making a lot of stuff.
Experimentation. Yeah.
Yep. That's good. Well, that's good though. So you guys and you guys see like I guess you said you only have like a couple people present per meeting and everything.
Well, we do like one or two like informational talks, and then we open it up for demos and pitches. And usually we have anywhere from 4 to 8 little demos.
Oh, that's not bad.
Yeah, it's pretty good. Just last week we had a guy named Jack Minardi who won the hardware hackathon in San Francisco. I think in February. He did like a haptic glove with a Raspberry Pi.
Mm-hmm.
And
I remember seeing an article about that. I think it's TechCrunch or something.
Yeah, and
wrote it up.
And the other cool demo we had was guys in Austin starting a company called Sapphire OS. You should definitely check it out. It's a wireless kind of mesh network of programmable elements. And so you can build a lot of things on top of it. But the demo they had was showing off the synchronization and controlling some RGB LED strips around the room with these little nodes.
That's really cool.
Looked like a pretty seamless interaction. So I think they put a lot of work into the whole stack to make it kind of painless.
Yeah. Well, and you know the pain of all that, right? So
yes.
So I saw your Halloween costume this past year. Tell us about that. That was a fun project.
That was a fun 3 weeks of late nights. So my friend Matt and I drafted him to help me. He's a really good developer and hacker as well. So we built a family of Roombas. So my 2-year-old was to be the Roomba because he's crazy about it. And my wife and I were to be the virtual walls, which are the things that keep the Roomba from going beyond the boundary that you want it to clean. And so it was a nice kind of theme. But in our neighborhood, it's kind of like a big, once it gets dark, all these houses kind of have haunted houses, and it's a big party in the streets.
Nice, yeah.
And so we wanted something to liven it up after dark. So Matt and I came up with these LED rings using just those LED pixels, strands, and control them. They each had a little Arduino micro on them to control them, but we used these little custom IR boards to allow them to synchronize. And like you said, that was the tricky part that took a lot of the time. Construction and hot glue and all that takes a good amount of time, but getting the communications protocol to allow them to change patterns and update the same light at the same time was we got working about 4 a.m. on the day of Halloween.
Oh, yeah. That's how it usually goes, right?
Yeah, exactly. Well, that's the thing. Like, one thing that I repeatedly learn with these home projects is, boy, it helps to have like a hard deadline that's out of my control.
Yeah.
And Halloween is one of those deadlines. And Maker Faire, right? Like, a lot of people build projects for Maker Faire. I think that's another good reason to do that.
Yep, I agree. Otherwise, you just keep stringing it along.
Yes.
I know how that one goes.
Yes.
Well, that's good. Yeah, and I remember the picture then of it seemed like the ultimate uncontrollable part of your design was your son's cooperativeness of that final picture.
Well, there's a lot of things you can engineer, and the willingness of a 2-year-old to put on a costume that you spent hours and hours and hours designing for them, it should have been a known going into this deal.
Right. Oh yeah, I mean, that's the Murphy factor on that has got to be well in excess of the standard deviation.
Yeah. So that was kind of a fail. The other drawback of it is so we did all this work to get him to synchronize. I'd say about 10 or 20% of the people on the street even understood that was a unique and difficult thing to do.
Right. Oh, yeah. Yeah,
but
just the general normalization of technology. Of course it can do that. It's blinking lights, right?
Right, exactly.
Whatever.
Why wouldn't they synchronize? Yeah.
Right, exactly. Yeah, that's crazy. But it's a really fun project. And you have that one on your site. You have that and a couple other fun projects as well. So people should definitely check out. What's your website?
It's just my
URL.
initials rhb.me.
Okay, nice and short and easy. That's cool.
Yeah, it's
so.
you gave a presentation last year at Maker Faire about the importance of documenting and sharing your projects, I recall. And
Yeah.
I continually remember that when I fail to do it. Because as it's probably 20% of the time to actually do it, and 80% to document in a nice way that other people can use it. So I have definitely failed in that regard, and some of the things I've built would be very easy to post the code and share, but boy, it's hard to make time to do that.
Right. Well, especially when on to focus on the other stuff too. It's like, yeah, I remember I've been cutting with the CNC machine, right? I'll cut, pocket in metal, right?
Yeah.
That's great. Okay, cool. I feel so accomplished. It's like, okay, well, I should go process the video, and yeah, editing video and uploading and everything. It's just like, what? Look at this time skew. I gotta hire someone.
I appreciated that. I watched your video of what failures in a resolution, and I thought that was really great. How you kind of went through each one and said, "Oh, I think this is wrong, and I think this is the fix." And so I know that took a lot of work, but I appreciated it.
Yeah, well, it's nice. I mean, it's good because a lot of people online have been helping me too. So that's nice.
Pay it forward.
Yeah, exactly. So you've been a Tech Shop member as well. I mean, I guess you probably get some in-person assistance, right? From
Yes.
Tech Shop.
Yes.
What's that experience? I know some people who've done it out in California, but it feels like they get all the benefits anyways of being in California, so it's kind of skewed.
Yeah.
So what's the Austin one like?
Oh man, I love it. We got the Tech Shop. I think the opening or the soft opening was mid-October of last year, and ever since then, there's been a core group of guys here from NI who pretty much anytime you go there, one or more of us is there, and there's a little bit of a lag because you have to take what are called the safety and basic use classes to get access to different tools, but once you're kind of got the core that you want to use taken, it's been awesome.
Yeah. So what kind of stuff have you taken so far?
So the laser cutter is the most popular tool. So generally advised to grab that one as fast as you can. But beyond that,
yep.
I've done the ShopBot and I've done the WaterJet, the two kind of big CNC tools. I haven't done the Tormach yet. I've done the manual mill.
Oh.
I've done the wood lathe. I've done the wood shop and the metal shop. I've done powder coating, which is pretty fun. I've got, I think, silk screening next week.
Oh, I didn't know they had that there.
Yeah,
that's pretty cool.
Yeah, and they have a CNC vinyl cutter too that I'd like to take. So I've spent a fair bit on the Tech Shop classes, but now I'm at the point where most of the things I want to build I have covered, or with this kind of, we have a shared spreadsheet among people at NI showing who's taken what class, and I think we have pretty much everything covered.
So is it like you can go, it would be like you would go ask someone to make something for you at that point, or you'd actually have them help you out? Is that kind of the idea?
Yeah, I'd stand next to them, but yeah, we'd probably barter skill for skill. I haven't gotten to that point yet, but most people like an opportunity to practice with a specific goal in mind, so it hasn't been a hard sell to get help.
Well, that's good. That's good. So, so like you said, a lot of the people at NI are doing that. Is it kind of like, are you guys allowed to use that as like a secondary workshop for like prototyping ideas? Is that kind of the idea? Is it kind of company sanctioned, or how's that working?
Well, so my colleague Tim and I were huge Tech Shop fans, and we joined basically on day one. And so we actually were able to arrange for a collaboration between National Instruments and Tech Shop for the Austin location. So we provided LabVIEW and MyDAC for the Austin Tech Shop.
That's great.
We're teaching LabVIEW classes and measurement classes, and we're working on a basic electronics class that'll kind of use some of those tools, but I guess technically they're workshops and not classes, but teaching people kind of in Tech Shop, most of the training is with a specific project in mind, or at least many of the students may not want to become experts in how to use a mill or a ShopBot. They want to build a chair or, build their bottle opener or some specific project. So the project-based stuff is equally important as kind of the general skills, and we're hoping to kind of mix those two things together in this basic electronics class.
Huh. Well, no, that's a good idea. I mean, I've heard other people say that too at other tech shop locations. Is that the the mechanical stuff is really really solid. I mean, but then the electronic side, there's labs, there's some available equipment, but it's more of the people who are gung ho about the mechanical stuff usually aren't bothering to do the electrical stuff, or it's easier to outfit a small bench at home versus going to tech shop for that kind of thing.
Yeah,
so that's good you guys are doing that, though.
Yeah, we are definitely because it's in Austin, we can have LabVIEW developers teaching the LabVIEW classes, or
yeah, exactly right.
And so that's the other great thing about Tech Shop is a lot of the teachers are people that you might have a hard time getting access to otherwise. The several UT professors teach some of the machining classes, and
that's awesome.
I don't think they do it for the hourly pay they get. They do it because it's a cool community and they get access to Tech Shop in return, and they like helping people build stuff.
Yeah, definitely. So you building anything cool that you're allowed to talk about, or is that kind of still waiting, still building that ever growing list of skill sets?
Yeah. So I've been kind of hooked on the water jet.
Yeah. And are you cutting steel, or what are you cutting with that?
Mostly steel. Yeah, I haven't done granite or anything else, but
granite. I didn't know you could do granite. That's awesome.
I don't know. There's a few things you can't do. You can't do tempered glass. You can't do things that'll shatter, basically.
Right.
But people have done copper. People have done plywood that I've seen. But yeah, I've done mostly steel, and I've done some house numbers, some bottle openers. We for South by Southwest, we had 4 days to build a robot. So
really,
me and the Waterloo Labs guys, one of their guys, a mechanical engineer, designed up this platform because they wanted this. They were going to use a first robotics base as the mobility platform, and then they wanted to build a torso that could hold platforms or platters and navigate around a party. And
is this to make the R2D2 appetizer server type of thing? Is that the idea?
I didn't get invited to the party, so I can't say.
What? Oh, jeez! And you helped cut this stuff?
Yeah.
You should have put it in like a hidden kill switch. Oh, it's not working. Yeah. I guess I'll have to stop by.
Yeah. Well, I guess during South by Southwest, there's so many parties.
Yeah.
There's not a shortage, but we cut. He designed it. I showed him how to use the FlowJet software. We cut it on a Friday night. He welded it on Saturday. They added the stepper motors. They needed is it one or two for rotating the platters around, and they had a face that did text to speech and speech recognition using LabVIEW on a tablet. And on I think Monday
awesome.
night it was at a party. So
yeah. That right there, folks, is the reason that that kind of LabVIEW prototyping stuff. That's the things I've seen before too, where it's just like snappy turnaround, drop a module, and especially when you might have access to some of that software at a moment's notice, right?
Yeah.
It's like you drop it in there though, and there's maybe even example code and stuff, and yeah, it's great. You just go.
Yes, yeah.
So.
And I don't think it hurt anybody. I don't know if they had time to.
Oh, good. No toes rolled over.
Yeah, the 3 laws, but no. I don't hear of any casualties.
What? NI doesn't have a 3 laws module yet for LabVIEW?
That's an expansion pack.
Yeah, you can't afford it. Believe me. Well, that's good. No, so you mentioned Waterloo though. So have you worked with them other times as well?
No, not a lot. This was the first time I'd actually helped them build something. They're kind of came out of one of our other departments, and I think most of it's been in their free time. But they are making these. If you haven't seen them before, Waterloo Labs. I think it's waterloolabs.com. They make videos that happen to use LabVIEW and other NI hardware to build something interesting and unique, and in doing so, they hope to get people and students excited about engineering and technology. That's kind of the underlying message. But I think they got the most attention for their iPhone driving a car. So they were surfing on the car and steering with the iPhone.
Which in itself is pretty ballsy to be standing up on the hood of a car.
Yeah,
but
it is.
I was interested in that because I thought that was going to be like, plugging into whatever the port thing is on a car, but they were actually doing like gears and chains in order to actually move the steering wheel, and then there was like actuators pushing the pedals. So
Yes.
it was kind of like in Ocean's 11 when they had that robot driving a van, like that kind of style. If people can visualize that,
It was pretty rigged. Yeah. I remember some of they used they welded a wrench on to the actuator to push down the gas or the brake, and like you said, it was like a bike chain to the steering column. But it worked, and it was pretty cool. They did recently.
You see it in person or no?
I didn't see the car moving in person. It was in the parking lot for quite a while.
Yeah, I think didn't they tour it around too? I thought I might have seen that at Maker Faire or ESC or one of those.
Oh, I'm not
things.
sure. Maybe.
I thought they might have. Maybe that's how I saw it. I don't remember. I have a terrible memory.
They recently did the real life Mario Kart where they rigged up go-karts to detect the turtle shells and banana peels, and they tied into the gas and the brake and the steering wheel. So when you hit like a banana peel, it jerked the wheel and slammed on the brake.
Yeah.
Which I thought was pretty funny.
Yeah.
They did a real life first person shooter, but all these videos are online.
They have a good YouTube. But I remember is they did sensing. They did muscle twitch sensing around the eyeballs in order to do eye tracking for Mario.
That's right.
To actually play the game, I think it was like blinking made Mario jump, and then you could kind of make it track on the screen by moving your eyeballs and stuff.
That's right. Yeah,
it's cool stuff. I like it.
Yeah. So
hopefully you'll get to do more videos with them or work with them more. That'd be cool.
Well, they're going to be one of the big users of Tech Shop, because for them it's all about doing things fast and having access to a number of different tools to build these kind of oddball contraptions.
Yeah. Well, anything else we should know about here? Because this has been. I'm going to have to be posting a lot of awesome links here. I'm very excited about sharing all these links with everybody. Not so much about the finding and posting them.
I think that covers it, Chris. We were talking. What are we going to talk about for an hour? But I guess we covered it, didn't we?
Oh, there's never a problem there. Okay, so then the important question as a former Austinite, what is the must-have barbecue for the meat eaters out there? What is your number one?
Oh gosh. Well, the new let's see. Since you've lived here, is Franklin is the one that every day literally has a line around the block to get their brisket. So.
Is that the one that only is open like 4 hours a day? Is that the one?
Well, they close when they run out, so that ends up being 4 or 5 hours a day. It's on 11th near I-35. But yeah, Franklin is really good. There's a couple of Style Switch and Mann's that have been around.
I've ever had those.
So Mann's is a couple, I think, retired couple from Georgia. And they have a really good barbecue, and then Style Switch is newer. He's a fellow Texas A&M Aggie, so I definitely want to support those guys.
Gig 'em. Yeah.
Yeah, so we have lots of good options for tacos and barbecue. Maybe many of which. When did you move away?
I came back up here in 2008.
2008, so
it's been a while. I've been meaning to get back down there, but it's just never really you'd think Cleveland winters I want to get back down there, but I'm hoping for South by Southwest next year I'll be able to get down.
Definitely.
Yeah. All right, cool. Well, people can find Ryan at rhb.me, or you can find all the cool stuff that Ryan's working on. We'll have links for everything, Flex Rio and all the other projects, the ATX Hardware Meetup and Tech Shop and everything else. We'll have all those links in the show notes tonight. So, Ryan, thanks for being on. You carried the show when Dave wasn't here. Hopefully we can have you back on when he's back in town.
Yeah, awesome, Chris. Well, thank you for having me. I'm really excited to talk to you, and hopefully I'll see you out, if not at Maker Faire, maybe at South by next year.
All right, thanks again.